Today, I'll be talking about a topic that might seem simple at first but is actually foundational to many areas in computing. The fundamental of counting. I chose this concept because mathematics is deeply woven into information technology, and counting principles are one of the core buildings block behind algorithm, data security, and system design. Even though we don't always notice it, that these ideas work behind the scenes of almost every technology we use. What are the fundamentals of counting? The fundamentals of counting refer to mathematical rules that help us determine the number of possible outcomes in a situation. The two most important ideas are the additional rule. If one event can occur in a ways and another completely separate event can happen in B ways, then together they can happen in A plus B ways. The multiplication rule. When one event can occur in A ways and a second event can occur in B ways after the first, then the total number of ways both events can happen is A times B. In a simple terms, add when you're choosing either option. Multiply when you're choosing sequence of option. This principle helps us answer a question like how many possible passwords can be created? How many different routes can a piece of data take through a network? Or how many different configurations can a system have? How counting applies to information technology. Now, let's connect this to the world of IT. Password and security system. When creating password, system rely on counting to measure password complexity. For example, if a password is 6 character long and each character can be a letter or a number, counting principles help calculate how many possible password combinations exist. The larger the number of possible combinations, the harder it is to crack the password, meaning better security. Computer networking. Routing algorithm in networks, such as those used by the internet, rely on counting to determine how many possible path data can take between devices. Network engineers use counting principle to estimate possible IP address combination, available port number of path during packet routing. This ensure efficient communication and prevent system overload. Programming and algorithm design. When programmers build algorithm, especially for searching or sorting data, they often need to estimate how many operations an algorithm might perform. Counting helps them measure algorithm complexity, which is essential for writing efficient code. Databases and data structures. Database designers use counting to determine how many possible record combinations can exist or how data can be arranged. For example, indexing data, retrieval, and hashing all use combinatorics and counting principle to optimize performance. What I learned about the importance of mathematics in IT. Studying the fundamental of counting made me realize that mathematics is just a subject we learn in school. It's a language that technology speaks. Here's what stood out to me. Math helps us build secure system. Without counting principle, cybersecurity would be blind to the strength of encryption and password. Math helps system run efficiently, algorithm improve speed, and reduce wasted processing power because developers understand the math behind complexity. Math provides structure from network working to data storage. Counting give us the ability to predict, calculate, and design systems that work reliably. In short, mathematics give information technology its logic, its structure, and its power. The fundamentals of counting may seem like a simple concept, but it formed the backbone of problem solving in IT. Whatever it's security data, writing algorithms, or design network, counting helps us understand how many possible texts exist and how to manage them. Thank you for watching, and I hope this helped you appreciate how mathematics quickly powers the world of technology.